of the entire conditional statement. Okay, does it make sense? Okay, in other words, if I'm standing here, and let me go back and use the pointer so I can record that too. So the question is, if I'm standing here, the conclusion, the only conclusion I can draw is post 2 or post 4 has to be true. At least one of the two has to be true. Because at that point, I don't know which path I took to get there. I only know that I'm at the merge. I'm at the point after the two paths merge, but I don't know where I came from. So the only conclusion I can draw at that point is, well, at least one of these two have to be true. Now, in some cases, they can both be true. There's nothing wrong with both post 2 and post 4 being true, but I can only confirm that at least one of them has to be true. Are we doing okay so far with this picture? Okay. So post 2 or post 4 is also known as post 5 because it is the end of the entire conditional statement. That's why it is also known as post 5. Are we doing okay so far with this code? All right. So now what we will do is we'll apply what we have learned here to the pseudocode that we were talking about earlier. I will use mouse pad to look at that, and I'll kick this picture around and maybe change the zoom a little bit. Okay. Is that still readable to you? Is it still okay? Okay. Because this way I have a little bit more space to write my post conditions, pre and post conditions. Put it here. All right. So in this case, I'm going to have a very specific example. I'm going to use the same thing as in the note here, which is if x is greater than y, then z gets x, line 3, else line 4, z gets y, line 5, and yeah. So we're going to use this particular example. And I'll say pre1 equals true. In other words, when I'm analyzing this particular pseudocode, I'm going to say, well, I don't know anything about x or y before the analysis. I'm going to make no assumptions whatsoever, and let's see what I can conclude at the end of the entire derivation. That's what I'm saying. So pre1 equals true, and then we will say, what is pre2? What is pre2? Pre2 is really this part here, right, in the picture, because it is before statement 1, which in this case is line 2 executes. It's pre1 and the condition of the conditional statement. Okay, we'll just follow that template. And I'll just say pre1 and the condition, which is x is greater than y in this case. And since we know what pre1 is, we'll plug it in, true and x is greater than y. And this is something that we did last time, on Tuesday. We can simplify this to just x is greater than y, because the value true is also known as the identity of conjunction. True and whatever is whatever. Are we still doing okay so far? Okay, so we have pre2 at this point. The next one, you can work on post2 if you want to, but I personally like to work on pre4 first because it has the same kind of template. So pre4 is corresponding to this part in the picture. So that means it is pre1 and the negation of the condition of the conditional statement. So in this case, it becomes pre1 and not x is greater than y. Pre1 is true because that's given. And in this case, not x is greater than y is also known as x is less than or equal to y. It's just simplification. You don't have to perform that step, but I like to change. I want to remove negation as much as I can, because it's easier to read this way. Okay, so now we have pre2 and pre4. It is time to work on post2 and post4. The post conditions of line 2 and line 4, they are both using the same rule. Okay, which rule should I use? Okay, let's see how we can analyze this and figure out how to work out the post condition. The right-hand side of line 2, does it refer or does it not refer to the left-hand side? Does not. Very good. Does not refer to the left-hand side. So which rule should I use? Use the forget rule. Very good. We use the forget rule because it cannot be undone. In other words, there's no inverse to go back to the previous value before line 2. Is that making any sense? Because line 2 completely overwrite the value of z without any method to reverse the operation. There's no way for me to get back to the value of z before the operation. Okay, so that means the post condition of line 2 is based on the precondition of line 2. We have to forget everything that we knew about which variable. The one that is changed on line 2. So which variable should we put here? Z. And then we know one thing for sure. After this, we know that z has to equal to x after the assignment, because that's the effect of an assignment statement. Now we expand what is pre-2. Pre-2 is just x is greater than y. We are still trying to forget everything about z. But after we forget, we also know that z equals to x. Is there anything to forget? Nope, because x is greater than y does not mention z whatsoever. So we end up with this as the post condition of line 2. Line 4, yep, go ahead.
With the forget rule, is like the way you write it, like pre-2 comma z, is that forget everything on pre-2 with respect to z, or?
Yes.
Okay.
Yep. Anything that mentions z, all the components that mentions z.
Before 2.
In pre-2. In pre-2, right.
Okay.
So the other one, line 4, is pretty much the same thing. Okay, the right-hand side of line 4 does not refer to the left-hand side. Use the forget rule again. So we say post 4 is, we have to forget something in pre-4. Anything that mentions z, we have to forget. And after that, we know that z equals y, because that's the effect of the assignment statement. And we'll carry out the operation just like before. We expand what is pre-4. Pre-4 is x is less than or equal to y. But since x is less than or equal to y does not mention z, there's nothing to forget in this case. And z equals y. That's post 4. What about post 5? Is that a difficult one or an easy one? That's a really easy one, because once you know what is post 2, which is the end, the post condition of one branch of the conditional statement, and you know the end of the other one, which is post 4 in this case, it is just a disjunction of the two. So here we can just say it is post 2 or post 4. And then the next line, I will just expand it. And since I have the editor, I have the advantage of being able to copy and paste. You don't have to copy and paste, you don't have to copy everything in your notes. What is more important is to understand what I'm doing and why I'm doing it. How does it work? Okay? The concept is more important. All right, so are we doing okay so far with this particular derivation? Starting on line 1, making no assumptions whatsoever between variables x, y, or z, and then getting to line 5, knowing that by the time we get to line 5, that condition has to be true. X is greater than y and z equals x, or x is less than or equal to y and z equals y. What is the significance of all this derivation, other than making this class unreasonably difficult? Yep.
Isn't it basically an assurance that both paths will work out? Because they'll both turn out to be true regardless of what the conditions are.
That is correct. Okay, so that's one way to put it. Okay, the way you mentioned it is one way to put it. Okay, so what we are doing here is to say, without knowing anything about x, y, or z on line 1, when the algorithm is done, we know for sure that this condition has to be true. So that yeah, go ahead.
Isn't this better than tracing? You have a general statement.
We have a general statement, okay? And tracing gives you a specific result given a specific input or given the specific test case, right? This one is universal, okay? You can throw anything at it. This statement has to be true, okay? Now, this by itself, post 5 by itself, is somewhat meaningless. Okay, yes, that statement has to be true, but what is the value of this post 5? The question. So, yeah, go ahead.
Finish your thought.
No, I want you to mention it.
I kind of follow up on his questioning. So, doing it this way helps us hammer out any illogical errors, and then the trays can, now that our logic is correct, use the trays for specific examples, specific, I guess, numbers or conditions.
Right. A trace can tell you the outcome of an algorithm given a specific test case. This gives you a conclusion regardless of the input. As long as your input is true, this is guaranteed to be the output.
As far as getting a specific output that you're looking for, the logic.
Aha! So you just got the point. The expected output, okay? What is the expected output of this algorithm? Now, if I didn't tell you what is the expected output of this algorithm, this entire derivation is pointless. But if I told you that this algorithm is supposed to find the maximum of x and y and store that in z, now we have something to work on. Because now we can look at this expression here and say, okay, is that really saying, okay, let's just focus on the last statement here, or the last condition here. Is this really saying the same thing as z is the maximum of x and y? What do you think? What do you think?
Yeah.
Yeah. Because when you define the maximum of x and y, then you have two cases, right? If x is the larger of the two, then we want z to be the same as x. Well, that's handled by the left-hand side of the disjunction. If y is the larger of the two, then we want z to equal to y, which is handled by the right-hand side of the conjunction. So this is truly, proving that the algorithm is finding the maximum of x and y. Yep.
We call Z just a dummy variable?
You can call it w. Yeah.
A dummy variable?
A dummy variable.
Is that right?
Z is not. It's there so that we can look at the output and actually associate the output of the algorithm and establish the relationship between the output and the input variables. So without Z, you can say, well, but what are you going to do with x and y, right? So Z is basically there as a placeholder so that we can refer to Z and say, okay, is that the maximum of the two? So in this case, I think intuitively you can see that Z is the maximum if that statement is true. Yep.
So we use a forget rule because x does not refer to y in the first statement.
Because y does not refer to Z. That's the reason why we have to use the forget rule. Yeah, we use the forget rule whenever we cannot undo the effect of an assignment statement. When you have an assignment statement like what we have here, let me just go back so that we can see the actual code. So when we look at a statement like this, there's no way for me to reverse the effect of this statement. In other words, if I know the value of z after line 2, there is no way for me to go back and say, okay, there's a way for me to derive the value of z before line 2. Now the other type of assignment statement where you have self-referencing, x gets x plus 1, there is a way to reverse it. But this one, there's no way to reverse it. Whenever you cannot reverse it, which means there's no inverse function, then you have to use the forget rule because there's no way to make any conclusion about anything that you know before about that variable.